Okay, this is part 2 of XEI 302. This video is going to be separate from our normal video because our extension skill here is kind of difficult, so I wanted to spend a lot of time on this. So here in these examples, I want you to take a look and see how they're different from what we've already looked at. Now, I see variables on both sides here of my equation. Whenever that happens, I would like you guys to try to move the variable on the right-hand side to the left-hand side. Now, you might have been taught already that you can move it to either side, so if you're comfortable moving variables from the left to the right or from the right to the left, it's up to you how you want to do it. I just like to stay consistent with you guys, so I'm going to solve it every single time the same kind of way so that you guys get practice seeing it over and over and over again. So I'm going to start here in 9a by subtracting 2x to the other side here. Now I can combine 3x and 2x because they're like terms. So 3x minus 2x gives me x, and I have x plus 5 equaling, on the right hand side, just the negative 4 is left over. And then when we get down to here, this equation is probably very easy for you to solve now. So here we're just going to subtract 5 first, and we end up with x equaling negative 9. So now it becomes a really easy one-step question after we get the variable to the right hand, from the right-hand side to the left-hand side. So let's try that one more time. Here's b. In b here, I'm going to add 2y so that I can move it over to the left-hand side. Since I'm adding 2y, that's going to cancel. So now it's no longer on the right-hand side. Once I add it to the other side, I end up with 4y plus 2y gives me 6y. So I have 6y minus 11 equals 1. Now, I have a two-step equation here. I'm going to add 11 to both sides here so that I end up with 6y. These will cancel. Bring down my equal sign. 1 plus 11 gives me 12. If I divide now by 6, to undo that operation here, it's multiplication. I divide by 6. I end up with y equaling 2. So again, it starts by making sure we always move the variable on the right all the way to the left side first. Let's try C. Now C looks a little bit different even than the ones we just worked on, because in C we have some parentheses. So we're going to work on the skill that we started off with, which was the distributive property. So we practiced that a few times so that we'd be ready for this question here. We're going to distribute the 2 to the x and the 7. So I end up with 2x plus 14 equals negative 3x minus 6. All right, now this question looks like it did in parts A and B. So it's similar to what we just learned. We're going to move the negative 3x, we're going to move that to the left-hand side. In order to do that, we have to add 3x to both sides. So I add 3x, and that gives me, since those cancel on the right, gives me on the left-hand side 5x. So I have 5x. I'm going to copy down that plus 14, bring down my equal sign. Since this cancels, I don't bring that down, but I bring down the minus 6 here, so it's a negative 6. Now, if I want to solve for x, I need to get rid of the 14. So I'm going to subtract 14. This will cancel the 14 here. Leaves me with 5x. Bring down my equal sign. Negative 6 minus 14 is negative 20. Now I can get rid of the 5 here. 5 times x needs to be undone by dividing by 5. And that leaves me with just x after I divide by 5. So I have x equaling negative 4. Okay, part D here is even trickier than the last one because we have two parts that have the distributive property. So on the left-hand side, I'm going to work to distribute this 3 to both of these terms, and then I'm going to do the same thing with the 4 to these terms here. So I start by just distributing. So 3 times x gives me 3x. 3 times negative 2 gives me negative 6. On the right-hand side, I have 4 times 2x, which gives me 8x. 4 times 1, which gives me a positive 4. Now, I want to move this variable from the right-hand side to the left-hand side. So I will subtract 8x on both sides. Once I subtract 8x, these will cancel here. 3x minus 8x gives me negative 5x. Bring down my minus 6. Then the equal sign. And then here, since this canceled, I just have to bring down that positive 4. I don't need to write plus 4 since I know it's positive. I can just write the 4. Okay, now I need to solve for the for the x. So in order to do that, I need to first move this negative 6. So I'm going to add 6 on both sides here. Those are going to cancel. I'm going to drop down that negative 5x now. And on the right-hand side, 4 plus 6 gives me 10. Now at this point, I can divide by negative 5 so that I end up with x equaling 10 divided by negative 5 gives me negative 2. And this is actually my final answer there. So it was a lot of steps, right? We had, let's see, 1, 2, 3, 4, 5, 6 different steps in just one problem. So you have to be very consistent, and you have to show work every single time. If you mess up on a step way back here, then all of this, from here on out is going to be incorrect. So you got to be really consistent and really careful when you're solving these problems. All right, next up is E. Now in E, I don't have any distributive property here, but I do see on the left-hand side, do you notice how you've got an x here and an x here? What you want to do is combine these first. So I have 4x minus, this is 1x here. 4x minus 1x gives me 3x. So I have 3x, then minus 3, right? This is still minus 3 here, equals negative 2. And now this looks like a question that we've already worked on a few times. We're going to add the 3 first, so we get rid of that 3 first. These will cancel here, leaving me with just 3x equaling positive 1. Negative 2 plus 3 is a positive 1. To undo 3 times x, I must divide by 3. So now I divide by 3. This will cancel here on the left-hand side and leave me with x equaling 1 over 3 is 1/3. And there is my final answer here for E. In F, let's work on this one. This one's kind of a tough one because we've got a fraction here in front of the parentheses. That's okay though, we're still going to distribute. 1/3 times 1x gives me 1/3 x. So that one's not too bad. 1/3 of negative 6 is negative 2. So that's something I would type into my calculator if I wasn't sure about that. Then I have on the right hand side equals 2/3 x. Now I picked this kind of problem here because let's say we decide, because I always want you to subtract this variable here to the other side, right? I always want us to move the right variable to the left. So I'm going to subtract 2/3 x. Okay, now when I subtract 2/3 x, what am I left with on the right hand side? What would 2/3 x minus 2/3 x give me? If you're saying 0, you're absolutely correct. You need to make sure you put a number here. So we usually just cancel it out. We don't show the plus 0, but in this case we want to show that because otherwise we have nothing on the right hand side. So I'm going to put the 0 here. Then on the left hand side, 1/3 minus 2/3 x gives me negative 1/3 x. Then I have this minus 2 here. Alright, next I am going to add 2 on both sides. Adding 2, now it's going to cancel. So this is what I mean by we don't usually put the plus 0 here because we don't really need it since we already have something left over. We have the negative 1/3 x left over. On the right hand side though, we have 0 plus 2, which gives me 2. And now we're just using one of the skills that we just talked about in part 1 of the video. We're going to multiply now by the reciprocal here, which is going to be negative 3 over 1. So we multiply by negative 3 over 1 on both sides. That'll cancel this fraction here that's attached to the x. So I have x equals 2 times negative 3 over 1 gives me negative 6. So there's my final answer for number F, or for letter F. So that one's a tough one. Again, you had a lot of steps here, okay? Alright, you guys are going to work now on these next You Try It questions. These questions, all of them, look a lot like the questions that you just worked on. So make sure that if you get stuck, you can always look back here. They should mimic, even part D here looks like part D here. So it's very similar, and you can kind of just get that practice so you get a little bit more comfortable with those. I'm going to do one more problem with you, and that's going to be a word problem. So you're going to be given some questions, and I actually took this question almost directly from a skill sheet. It's going to give you a scenario, and it's going to give you an equation as well. So I'm going to read it out loud first. It says a swimming pool club charges non-members $8 per day to use its pool. Members have to pay, though, an upfront fee of $250, and then they can pay $5 to use the pool per day. So in other words, members get a slight discount. They only end up paying $5 a day to use the pool, while people who don't pay the membership fee have to pay $8 a day. So they pay slightly more, but they never have to pay that upfront fee. So we want to find out how many times you have to go to the pool in order to justify becoming a member. Because if you don't go to the pool very often, then you end up paying $250 out of pocket, and that's a lot of money. So we want to figure out how many times you need to go in order for it to actually make sense for you to pay that membership fee. So they give you an equation, so that's nice. We don't have to set one up. It says 8x is equal to 250 plus 5x. So we're going to solve this equation. So I start by writing this equation down, and I'm going to solve for x. So again, I see a variable on the right hand side, so this looks like what we were just working on. We're going to move that to the left. So I will subtract 5x on both sides. Now I'm left with 3x here equaling 250. So this is going to cancel on the right hand side, right? Just leaving you 3x equals 250. Now I'm going to divide by 3 on both sides so that I can isolate x. So now I have x equaling, and this is going to give me a decimal, okay? Okay, so after sticking that in the calculator here, I get 83.33. So repeating. Now, part B here says to explain what this solution means. So that's really the important part in this question, is to make sure you understand what the scenario is. So remember, we said that a non-member has to pay a little bit more every day. They pay $8 per day. A member pays an upfront fee of $250, so they have to pay a lot upfront, but they get a little bit of a discount every time they use the pool. They only have to pay $5. So let's decide, is it actually worth it to become a member? Okay, is it worth it to pay that fee up front? Well, what this is saying here, this 83.33, since we can't go 83.33 times, I actually am going to round this up. At 84 times, it becomes cheaper to be a member. Because on the 84th time that you go to the gym, you're paying a little bit less than somebody who's gone 84 times who's a non-member. So really what this is saying is, if it's going to be worth it for you, you have to figure out how many times you want to go to the pool. If you don't go to the pool more than 84 times, then you're better off paying just $8 an hour, or $8 per time you use the pool. So in this case, it just tells you, which one is going to be cheaper for you. So basically, this is the amount of times you go in order for you to pay the same amount. So in order for the non-member and member to pay the same amount. And of course we can't go 83.33 times. So really, if you go only 83 times, it's cheaper for you to be a non-member. As soon as you go 84 times, though, it becomes cheaper for you to be a member, because you're paying a little bit less at that point. So hopefully that makes sense to you, because you will be doing some questions that are like that. If you have any questions, though, please make sure you ask, because I know that's a kind of a tough concept here. But luckily we get at least, we don't have to set up the equation here. We're just going to be able to solve the equation, and then we interpret the answer based on the context of the question. All right, that's the end of part 2. So go ahead and get to work on your skill sheets and then ask lots of questions.